For any triangle ABC, we need to prove the following. Let us begin. Now first, let's go through some terminologies. Let's say we have a triangle ABC. Then the sides opposite to the angles A, B and C are going to be denoted by the letters A, B and C respectively in lowercase. Then the semi-perimeter of a triangle, which is defined by S, this is going to be take the perimeter and divide it by 2. Okay, with this we'll start from the left hand side. So here on the left hand side we have B minus C multiplied to cotangent of A over 2 added to C minus A times cotangent of B over 2 added to A minus B times cotangent of C over 2. Okay, now there's a standard formula for each of the cotangent function. It's the half angle formula. So here we will first use the value for cotangent of A over 2. That's going to be given by square root of S multiplied to S minus A divided by S minus B times S minus C. This will get added to C minus A multiplied to cotangent of B over 2. So B cotangent of B over 2 is going to be the square root of S times S minus B whole divided by S minus A times S minus C added to A minus B times cotangent of C over 2. That's going to be the square root of S multiplied to S minus C whole divided by S minus A times S minus B. Fine. Now let's solve this. Now in each of the terms we'll see that from the numerator we can factor out square root of S. This is going to help us simplify the problem. So here what we'll do, we're going to add each of the three terms. So that's going to give us, so here in the numerator we have B minus C multiplied to S minus A added to C minus A times S minus B added to A minus B times S minus C, and the denominator is going to be the square root of S minus A times S minus B multiplied to S minus C. Okay, we'll try to compute the numerator portion. So here we have square root of S whole divided by the square root of S minus A times S minus B times S minus C. That will get multiplied to, so B minus C times S minus A, that's going to be BS minus AB minus CS plus AC added to C minus A times S minus B, so that will be CS minus CB minus AS plus AB added to A minus B times S minus C, so we have AS minus AC minus BS plus BC. Now here we'll see that each of the terms will get cancelled out, leaving us with 0. So this entire expression will be 0. So we have 0 multiplied to square root of S over square root of S minus A times S minus B times S minus C, and that's going to leave us with 0, which is the expression on the right hand side. Hence proved.